In this video, we will delve into the world of unions, a powerful feature in C programming. You will learn what a union is, its syntax, and how to declare it. We will also cover the essential topics of defining and creating union variables, accessing union members, and understanding the size of a union. To top it off, we will compare structure and union, emphasizing their differences. Let's get started. First, what is union? A union is a user-defined data type in C that allows you to store different data types in the same memory location. All members of a union share the same memory space. This means that all members of a union occupy the same memory location. When you assign a value to one member, it overrides the value of any other member that was previously stored in that memory location. The size of the union is equal to the size of its largest number, meaning that the size of a union is determined by the size of its largest number. This is because all members share the same memory space and the union must be large enough to hold the largest number. And only one member of a union can store a value at any given time. As I mentioned earlier, when you assign a value to one member of a union, it overrides the value of any other member that was previously stored in that memory location. This means that only one member can store a value at any given time. Writing to one member will override the other member's values. And this is a direct consequence of memory sharing and single active member properties of unions. That is, when you write to one member, it overrides the value of any other member that was previously stored in that memory location. By understanding these key properties, you can effectively use unions in your programming to conserve memory and create flexible data structures. Let's see an example that demonstrates memory sharing, size of a union, single active member, and overwriting values in a union. Now let's go through the code line by line. First, include a standard input-output header file, which is necessary for using printf and other standard I/O functions. Next, we defined a union named data that contains 4 members: int I, an integer member; float f, a float member; double D, a double member; char str20, a character array member with size of 20. Unions can hold only one of these members at a time because all members share the same memory space. In main function, we declare a variable myData of type union data. The lines 12 to 15 print the memory addresses of union members. And all these addresses should be the same, showing that all members share the same memory space. Line 17 prints the size of the union data using the size of operator. The size of a union is the size of its largest number, the character array str20 bytes in this case. Next, we demonstrate that only one member can hold a value at any given time. First, we assign 10 to myData.I and print it. Next, we assign 3.14 to myData.f and print it. So when we print myData.I again, we see it has been overwritten, indicating that union can hold only one active member at a time. Finally, we show that writing to one member overrides the value of the other members. We use snprintf to safely assign the string hello union to myData.str and print it. Then we assign 3.14159 to myData.d and print it. When we print myData.str again, it shows an overwritten or garbled value because myData.d has overwritten the memory space. And return 0 indicates the successful execution. Now let's run this program. You can see all members of the union data share the same memory address, and the size of the union data is 24 bytes, and this is due to padding for alignment. We'll discuss this later. Here we set the int member I to 10 and prints it. After which we override the int member I with the float value 3.14. Now the int value 10 is lost and we print the float value. Here I is assigned again. We get this value. This value is not the original value 10 because the memory location still contains the binary representation of the float value 3.140000. So this int value is the result of interpreting the binary representation of the float value 3.140000 as an int. Next, we override the int member I with the character array hello union. Now the above int value is lost. This will override the character array member str with the double value 3.14159. Again the string hello union is lost. And this will override the double member d with the new character array. At this time the string is not valid C string because it contains non-ASCII characters and it is not null terminated. This is because the double value was written to the same memory location, which caused the character array to be overwritten with a garbled value. So this output shows how the values are overwritten when we assign new values to different members of the union. Now let's understand the syntax and declaration of a union. The syntax to declare a union in C is similar to that of a structure, but with the keyword union instead of struct. Here is the syntax of union. Let's break down the syntax. Union is the keyword used to declare a union. Union underscore name is the name of the union. Type 1, type 2 and type n are the data types of the members of the union. They can be any valid C data types such as int, char, struct, etc. Member 1, member 2, member n are the names given to the members of the union. They are used to access the members of the union. This is a declaration of a union called data. Now let's break down the code. A union named data is defined with 4 members of different data types, and the members are int I, an integer member, float f, a float member, double d, double member, char str20, a string member with space of 20 characters. So the union data can hold the value of type int, float, double or char, but it can only hold one value at a time. This is because all members of a union share the same memory location. Now let's see an example to demonstrate the use of union. Specifically, it shows how a union named data can be used to store and access different types of data within the same memory space. First, include the standard input-output library necessary for using printf. Include string.h header file for string manipulation and character array operation. Next, define the union named data. The union data has 4 members: I integer, f float, d double, and str a character array of size 20. Next, main function is where the program execution begins. Then we declare union variable. A variable data of type union data is declared here. You can use it to store and access values of any of its members. Next, we assign values to union members. Line 13 and 14 assigns an integer value 10 to the member I and prints it. In line 15 and 16, we assigns the float value 3.14 to member F and prints it. In line 17 and 18, we assigns the double value 3.14159 to member D and prints it. In line 19 and 20, we copy the string hello union to the member str and prints it. Return 0 indicate successful execution. Let's run this code. And this is the output. The assignment data.I equals 10 assigns the integer value 10 to the member I of the union data. This line prints the value of data.I using the format specifier %d for integers. Therefore, we get this output. And the assignment data.f equals 3.14 assigns the float value 3.14 to the member f of the union data. And we print the value of data.f using the format specifier %.2f, which means a floating point number with 2 decimal places. And thus we get the output data.f equals 3.14. This assignment data.d equals 3.14159 assigns the double value 3.14159 to the member D of a union data. Next, we print the value data.d using the format specifier %.5f, which means a floating point number with 5 decimal places. So we get the output data.d equals 3.14159. Next, this assignment copies the string hello union into the member str of the union data. And we print the value of data.str using the format specifier %s for strings. For that, we get this output. Next, let's understand how union variables can be defined in multiple ways. When a union is defined, it creates a new user-defined data type. At this point, no memory is allocated. To allocate memory for a union type and work with it, we need to create a variable of that union type. There are 2 ways to define a union variable. First method is defining union variable with declaration. And second method is defining union variable after declaration. In first method, you can declare a union variable while defining the union type. This is the syntax. This declares a union type named union_name. Inside the braces, you define members of the union, and each with its own data type, type 1, type 2, type n. After defining the union type, variable_name declares a variable of that union type. This variable can be used to store any of the members defined within the union. In an example, union myData declares a union type named myData. Inside the braces, you define several members. Member I is an integer, member F is a float, member D is a double, member str is a character array with space for 20 characters. After defining the union type myData, data declares a variable of that union type. Now data can hold values of any of the members I, F, D or str defined within the union. Therefore, in this method, we are defining a union type myData and creating a variable data of that type at the same time. In method 2, we define a union type first and then declare variables of that union type separately. Look at the syntax. Here we define a union type named union_name. Within curly brackets, you list members of the union, each with its own data type, type 1, type 2, type n. And then we declare union variables. union_name specifies the union type that was previously defined. Variable 1, variable 2 declares one or more variables, and they can hold the values of the union type union_name. Now look at the example. First, we defined a union type named myData. Inside the union, there are 4 members. Union myData, data1, data2 is a union variable declaration. Here we declare 2 variables of the union type myData. The variables are data1 and data2. These variables can hold values of any of the members defined within the union. Let's look at an example which demonstrates how to define and use union variables using 2 different methods. First, include a standard input-output header file which allow the program to use functions like printf. From line 3 to 7, this block defines a union type named union method 1 with members I, F and str. Here we simultaneously declare a variable 1 of this union type. From line 9 to 13, this block defines a union type named union method 2 with the same members. This declares the union type without defining any variables. Next, main function. Here is where the program execution begins, after which we print the header indicating that the following output corresponds to method 1. In line 17, we assign the value 10 to the member I of the union variable 1. In next line, we print the value of variable1.I. In line 20, we declare a variable 2 of union type union method 2. This is method 2 where the union type was declared earlier and now the variable is declared separately. Next, we print a header indicating the following output corresponds to method 2 and adds a new line. In line 22, we assign the value 3.14 to the member f of the union variable 2. Next, we print the value of variable2.f formatted to 2 decimal places. Return 0 indicates that the program executed successfully. Now let's run this code. And this is the output. In the output, you can see variable 1 is a variable of union type union method 1 and it holds the integer value 10. Similarly, variable 2 is a variable of union type union method 2 and it holds the float value 3.14. Now let's move on and understand how to access union members. We know that union can hold only one member value at a time and the last assigned member is the one that holds a valid value. To access a union member, use the dot operator with a union variable. And if you have a pointer to a union, use the arrow operator to access its members. So use dot operator to access union members directly when you have a union variable. In this example, line 1 declares a union variable named data1 of type data. In line 2, we assign a value 10 to the integer member I of the union variable data1 using the dot operator. Use the arrow operator to access union members with a pointer. In this example, line 1 declares a union variable named data1 of type data. In line 2, we declared a pointer to the union of type data named ptr and initialized with the address of data1. There is ptr holds the memory address of data1 and you can use ptr to access the members of data1 using the pointer dereference operator asterisk. In line 3, we access the float member f of the union data pointed to by ptr and assign it to the value 3.14. By using the pointer to member operator, that is arrow operator, we can access the members of the union data through the pointer ptr, which points to the member location of data1. So in this case, line 3 is equivalent to data1.f equals 3.14 because ptr points to the member location of data1. Let's see an example which demonstrates the use of both dot operator and arrow operator with a union in C. First, include a standard IO library and then we define a union. Here we define a union data with 3 members, an integer I, a float f and character C. Next, we have main function. Here is where the program execution begins, after which we declare a union variable and pointer. Here data1 is a union variable of type data. ptr is a pointer to data1. Next, we access the union members using dot operator. So in this block, we assign value to data1's members using the dot operator and prints them. Note that each new assignment overrides the previous value because a union can hold only one member value at a time. Next up, we access union members using arrow operator. In this block, we assign value to data1's members using the arrow operator through the pointer ptr and prints them. Again, each new assignment overrides the previous value. Finally, the return statement, which indicates the successful execution. Now let's run this code. And this is what the output. Here the integer member I is set to 10, so we get this output. The float member f is set to 3.14, overwriting the integer member I, so we get this output. Similarly, the character member C is set to A, overwriting the float member f. And this is the output. Next up, the integer member I is set to 20 through the pointer ptr. For that we get this output. And the float member f is set to 2.71 through the pointer ptr, overwriting the integer member I. For that we get this output. And finally, the character member C is set to B through the pointer ptr, which override the float member F. Here the each assignment to union member overrides the previous value because union can hold only one member value at a time. Now let's move on and understand how to initialize a union in C. It can be done in several ways. Initialization at the time of declaration, initialization using a designated initializer, and initialization using an assignment. At the time of declaration, only the first member can be initialized directly. Here is the syntax and example. In this example, the union data is defined with three members, int I, float f, and char c. The variable data of type union data is initialized at the time of declaration, and the first member I is initialized with the value 10. In second method, any specific member can be initialized. Here is the syntax and example. In this example, union data is defined with three members. The variable data of type union data is initialized using a designated initializer. In this case, member f is explicitly initialized with the value 3.14. In third method, members can be initialized or modified anytime after the declaration. Here is the syntax and example. In this example, union data is defined with three members. A variable data of type union data is declared, and the member I is initialized with the value 10 using an assignment statement. Let's see an example program which demonstrates all three methods. First, include the standard IO library, and then define a union named data, which has three members. This means data can hold an integer, a float, or a character, but only one at a time. Next, the main function, which is the entry point of the program. In line 10, we declare a union variable data1 of type data and initialized with the value 10. In next line, we print the value of data1.I, which is 10. In line 13, we declare another union variable data2 of type data and initialized using a designated initializer. In next line, we print the value of data2.f, which is 3.14. In line 16, we declare a union variable data3. In line 17, we assign the value 20 to the member I of data3. Next, we print the value of data3.I, which is 20. And finally, the return statement, which indicates that the program is executed successfully. So, data1 is initialized at the time of declaration with integer value 10. Data2 is initialized using a designated initializer with a float value 3.14. And data3 is initialized using an assignment with an integer value 20. Now, let's run this code. And this is the output. Now, let's understand the size of union. The size of a union is equal to the size of its largest member. All the members of the union share the same memory location. Using size of operator, you can see the total amount of memory allocated for a union. Let's see an example. First, include a standard input-output header file, and then a union named data is defined. It contains 4 members, after which the main function. First, we print the size of the union data using size of operator. We also print the size of each individual members for comparisons. Now let's run this code. This is the output. The size of the union is 24 bytes. And this is because due to padding for alignment. Typically, int I requires 4 bytes, float f requires 4 bytes, and double D requires 8 bytes. Char str20 requires 20 bytes. The largest member is char str20, which takes 20 bytes, whereas double type requires 8-byte alignment. When a variable or data type is 8-byte alignment, it means its memory address is multiple of 8. So the nearest 8-byte alignment after 20 byte is 24 bytes, and thus the union is rounded up to the next multiple of 8, which is 24 bytes. Now let's see some difference between structure and union in C. First, let's talk about memory allocation. In a structure, each member has its own memory location. This means that each piece of data in a structure is stored separately in memory. In contrast, all members of a union share the same memory location, which means only one member can be stored at any given time. Next, we have size. The size of a structure is the sum of the sizes of all its members, whereas size of a union is the size of its largest member. Structure uses contiguous memory blocks for each member, whereas union uses overlapping memory blocks for its members. Structure is useful when you need to store multiple values of different types. Union is useful when you need to store a single value that can be of different types at different times. Structure can access any member at a time independently, whereas union can access only one member at a time. That is, the most recently assigned member contains the valid value. Next, structure can initialize all members separately, whereas union can initialize only one member at a time. Structure is used for complex data structures and records, whereas union is used for variant records and memory saving scenarios. Example for structure and union is given here. They may appear similar in syntax, but their memory management and usage differ significantly. That's all for this session. Thank you so much.